In the world of artificial intelligence, few moments have been as seismic as Google's defeat of Lee Sedol in the game of Go. In March 2016, AlphaGo, a computer program developed by DeepMind, a UK-based AI startup acquired by Google 2 years prior, defeated the South Korean Go champion 3-1. It was a moment that stunned experts and laymen alike, leaving many to wonder how this machine had achieved such a feat. But what's even more astonishing is that behind AlphaGo lies a seemingly innocuous tool, one that has been hidden in plain sight for years. You might have seen it before, but you probably didn't think much of it, the humble command line interface of Google Cloud. Within its unassuming pages lies a powerful secret, one that has enabled some of the most groundbreaking AI research in recent history. As we delve into the inner workings of AlphaGo, we'll discover how this free tool, yes, free, played a pivotal role in its development. TPU, or Tensor Processing Units, are specialized chips designed to accelerate machine learning tasks. And it's here that Google Cloud comes into play, providing researchers with access to TPUs without requiring them to invest in expensive hardware. But the significance of this goes beyond just Google's achievements in AI. What we'll explore next is how thousands of developers around the world have been quietly using this tool to push the boundaries of machine learning, and what they've discovered will leave you speechless. At the time, many thought it was a fluke, that Google had simply gotten lucky. But what they didn't know was that AlphaGo was just the tip of the iceberg. Behind the scenes, Google's AI team had been working on a top-secret project to revolutionize artificial intelligence. What we now know as the Google Brain team, led by Andrew Ng and Dandelion Project co-founder Greg Corrado, had been quietly experimenting with an innovative approach to machine learning. They were building upon the work of Geoffrey Hinton, a pioneer in deep learning who demonstrated that neural networks could learn complex patterns from vast amounts of data. Using this new approach, Google's AI team began training their algorithms on massive datasets, the likes of which had never been seen before. We're talking tens of millions of images, audio clips, and text files, all fed into a gargantuan neural network that was capable of learning at an exponential rate. The results were astonishing. In 2012, Google's AI team achieved what many thought impossible. They trained a neural network on over 10 million images and demonstrated that it could recognize objects with near-human accuracy. But that was just the beginning. The true breakthrough came in 2014, when their team developed a new architecture called the Inception module. This allowed them to process images at an unprecedented scale, setting the stage for AlphaGo's historic victory 2 years later. What many still don't realize is that Google's AI success story didn't end with AlphaGo. In fact, it was just the beginning of a new era in artificial intelligence, one that would change the game forever. In 2015, Google's AlphaGo AI program stunned the world by defeating Lee Sedol, the 18-time world champion in Go. This achievement marked a significant milestone in artificial intelligence research, but what many people don't realize is that this breakthrough was built on top of another groundbreaking development. The key to AlphaGo's success lies in an underappreciated tool, Google's Magenta project. Magenta is an open-source neural network library developed by Google researchers in 2016. Its primary purpose is to facilitate the creation and exploration of new musical styles using AI algorithms. On the surface, this might seem unrelated to Go or even computer science for that matter. However, what made Magenta truly remarkable was its ability to learn and adapt at an unprecedented pace. Researchers at Google discovered a way to use a type of neural network called a generative adversarial network, or GAN, to create new music samples based on existing ones. But here's the fascinating part: the same GAN architecture used in Magenta could also be applied to other types of data, including text and images. The implications were staggering. If a machine learning model could learn from and generate new music with such accuracy, why not use it to improve AI algorithms in general? The possibilities seemed endless, but there was one critical component missing: the ability for these GANs to operate at scale. It wasn't until 2017 that Google finally cracked the code. Their researchers developed a way to train massive-scale GANs using specialized hardware and a novel optimization technique called batch normalization. This breakthrough enabled the creation of incredibly large neural networks, capable of processing vast amounts of data in mere seconds. The resulting AI model was dubbed TensorFlow, an open-source machine learning framework that would eventually become the backbone of Google's AI infrastructure. With TensorFlow, researchers could build and train neural networks that rivaled those used by leading tech companies around the world, all for free. As we dive deeper into the secret behind Google's lightning-fast AI, it becomes clear that their success can be attributed to a combination of cutting-edge research and clever leveraging of existing technology. One tool in particular has played a crucial role in their advancements: TensorFlow. Developed by the Google Brain team in 2015, TensorFlow is an open-source software library for numerical computation. Initially designed to simplify machine learning tasks, it quickly gained traction as a versatile framework that could be applied to various domains. Today, it's one of the most widely used platforms for AI development worldwide. But what makes TensorFlow so powerful? At its core lies a concept known as distributed computing. By breaking down complex computations into smaller, manageable pieces and distributing them across multiple processors or even machines, developers can significantly speed up processing times. According to Google's own research, this approach enabled AlphaGo to analyze thousands of Go positions per second, making it an unbeatable force on the board. However, TensorFlow's true potential lies not only in its technical capabilities but also in its collaborative nature. By open-sourcing the platform and fostering a community around it, Google has empowered developers worldwide to contribute to AI research and innovation. As a result, we've seen exponential growth in machine learning applications across various industries, from healthcare to finance. But what are the real-world implications of this technology? As AI continues to permeate every aspect of our lives, its speed and efficiency will only become more critical factors. From medical imaging analysis to self-driving cars, high-performance computing will be essential for making AI a practical reality. With TensorFlow at their disposal, researchers and developers can push the boundaries of what's thought possible in AI, and that's precisely what we're witnessing today. Moreover, as AI becomes increasingly decentralized and democratized through open-source platforms like TensorFlow, we'll see more breakthroughs emerge from unexpected corners of the globe. Localized innovation will no longer be hindered by the limitations of centralized research institutions or commercial entities. This shift in paradigm is poised to accelerate progress exponentially, making the world a smaller, smarter place one computation at a time. As we dive deeper into the world of Google's AI innovation, it becomes clear that their success can be attributed to a specific tool, one that's been hiding in plain sight. In 2015, AlphaGo made history by defeating Lee Sedol, the world champion in Go, in a 5-game match. The implications were profound. An AI had surpassed human capabilities in a complex game. But here's the fascinating part: Google didn't create this breakthrough from scratch. They leveraged an existing technology to achieve their goal. That tool is called TensorFlow. Developed by the Google Brain team, TensorFlow is an open-source machine learning library that allows developers to build and train neural networks. In simpler terms, it's a framework for creating AI models. What's remarkable about TensorFlow is its speed. It can process vast amounts of data in a matter of seconds, making it an ideal platform for training complex AI models. And that's exactly what Google did with AlphaGo. By using TensorFlow to build and train the AI, they were able to create a model that could analyze 60 million positions per second. The numbers are staggering. In just over 3 years since its release, TensorFlow has become one of the most widely used machine learning frameworks worldwide. Today, it's estimated that thousands of companies, from tech giants like Apple and Amazon to startups and research institutions, use TensorFlow to power their AI projects. And Google continues to lead the charge, with recent advancements in areas such as transfer learning and reinforcement learning. But what makes TensorFlow so special? Its secret lies not just in its code, but also in its open-source nature. By making it freely available to anyone, Google has enabled a community-driven development process that's allowed thousands of contributors from around the world to improve and expand the platform. The result is a tool that's become an essential part of modern AI research, one that's been hidden in plain sight all along. The AlphaGo victory was a game-changer, marking the first time an AI had bested a human in a complex strategy game. But what many people don't know is that the secret to Google's lightning-fast AI lies not in some cutting-edge technology or proprietary algorithm, but rather in a free tool that's been hidden in plain sight. That tool is called TensorFlow, an open-source machine learning framework created by Google researchers. Developed specifically for large-scale deep learning tasks, TensorFlow has become the